Slideshow.
Okay, molarity. This sounds like it deals with moles again.
I see moles. Stoichiometry
Yes.
again.
Yay, stoichiometry.
Molarity measures concentration in liquids. This is actually a pretty simple concept. It's more or less an equation. Molarity is the number of moles
Divided by the liters of solution.
or moles per liter.
Yeah.
It's how much moles are in liters, your solution.
It looks like I could use a conversion factor there, molarity.
You can.
Oh,
It's also an
great.
equation. We'll get to some stoichiometry here in some practice. Again, molarity is a big M. This is new. The variable big M stands for molarity, equals moles per liter. And remember, moles is N and liters is volume. So big M equals moles per liter. These are the same thing, right?
Yeah.
Let's look at some practice problems. Curse you.
Okay, so what is the molarity of a solution consisting of 0.250 moles of sodium chloride in 650 milliliters of solution? Now, if I recall from that last slide, it said the volume needed to be in liters.
You're right, it did. So I'm going to write this down. I've got 650 milliliters.
Excellent. I always love writing the variables down. That's such a good thing to do.
But I need to convert that to liters. So divide by 1,000. Hopefully we know that at this point milli means 1,000. And we get 0.650 liters. Pretty simple example. Molarity, moles per liter. Big M equals moles per liter. So once I get my variables and they're in the right units, 0.250 moles over 0.650 liters. And if we plug that into our calculator, we get molarity, big M,
It's 0.385, sorry.
385 capital M. So for every liter of solution, there are 0.385 moles of sodium chloride.
So you can see the units on this answer is the capital M.
Big M,
So that stands for molarity.
molarity.
A concentration.
They get a little tougher, but not too much. What is the molarity of a 23.5 gram of potassium chloride? Let's just write that down to get our units out. Dissolved in water to make 850 milliliters of solution.
Okay, so what I'm seeing here is that we don't have moles now.
We don't have moles and we don't have molarity because we're asking for the molarity. But we do have grams. How do I get from grams to moles?
Well, we have to do some stoichiometry again, using the molar mass of our potassium chloride.
Molar mass, definitely the most common stoichiometry problem we've done. KCl, if I look that up on the periodic table, there are 74.55 grams of KCl.
Remember, that's just the mass of potassium plus the mass of chlorine.
And that is going to be 0.315 moles of KCl. Now I have my moles. I have my volume, milliliters again, so we need to convert. 0.850 liters divided by 1,000.
And we just plug this into the equation again, 0.315 moles over 0.850 liters, and plug it into the calculator, and presto changeo.
0.371 big M molar. All right, let's try one more example here because both of these we solved for molarity. This one, though, we're not trying to solve for molarity. We're trying to solve for volume.
Let's write out our variables again.
Let's do that. What volume in milliliters? Okay.
So yeah, so
Pay
volume we
attention.
don't know. V is like a question mark right now.
Of a 0.450 molar solution.
All right, so we have
big M,
molarity.
molarity of sodium hydroxide, could we make from 7.90 grams of sodium hydroxide, which is NaOH.
All right, so we have a mass of sodium hydroxide, which we can use to figure out the moles of sodium hydroxide, again, using the molar mass from the periodic table.
grams of NaOH. 40 grams of sodium hydroxide is the same as 1 mole of sodium hydroxide. So I can plug this in and I convert those grams and figure out that I have 0.1975 moles of NaOH.
Okay, we're going to use this now, so we know moles and we know molarity, but we do not know the volume, so we're just going to plug this right into our molarity equation.
Molarity equals moles per liter. I have the moles, and I do not have the volume. So the volume is going to be my variable down here, x. If I solve for x using a little bit of algebra, get the x all by itself, and we get a volume of 0.439, and there we go. That's the answer.
So yeah, we need to be careful when we do our algebra on these, just to make sure that we're doing it correctly.
And those are in liters because moles per liter, right?
Indeed, but we are looking for an answer in milliliters, so this would be kind of the right answer,
we're not
but
done
not
yet.
quite. Oh, that's sad.
All right, let's do that then. This is pretty easy. Liters to milliliters, multiply by 1,000. I can do that one in my head. 439 milliliters. If you need to do dimensional analysis, 1,000 milliliters is a liter, and we have a happy little answer. Molarity is pretty simple. Just kidding.